Good morning, dear students. Last class I have finished different types of problems from the lesson mathematical induction. That is, in the previous class we discussed about all types of problems of the lesson principles of mathematical induction. We collected those questions from exercise 4.1 and how we are giving a solution to the problems of mathematical induction. About that also I have told. Generally, the solution of mathematical induction problem is depending upon three steps, that is a basic step, induction step and conclusion step. Today also we are going to solving some different types of problems from the lesson principles of mathematical induction. Now let us, I am going to starting the first problem. Prove by principles of mathematical induction. Prove by principles of mathematical induction. Principles of mathematical induction. Prove by principles of mathematical induction. That is 1 square plus 2 square plus 3 square plus up down so on plus k n squared is equal to n into n plus 1 into 2n plus 1 whole dividing by 6. Whole dividing by 6. Now we are going to giving solution to this question is with help of three steps, that is a basic step, induction step and final step is a conclusion step. Now let us, we are going to giving the solution with the first basic step. Basic step now. Basic step. Let P of n is proof that. Let P of n is true for n is equal to 1. Last n term is there now. First term, second term, third term, up term, last one is n term. You collected n term here. N squared is equal to n of n plus 1 into 2n plus 1 whole dividing by 6. That is 1 square is equal to 1 into 1 plus 1 into 2 into 1 plus 1 whole dividing by 6. 1 square means 1 is equal to 1 of 2 into 2 into 1, 2 plus 1, 3 whole dividing by 6. Now 1 is equal to product of all the numbers in place of numerator, we are getting 6. 6 by 6 here and both are gets cancelled here. 1 is equal to 1 here. Therefore, LHS is equal to RHS. LHS is equal to RHS here. LHS is equal to RHS. Now in case of induction step first. Now let us, we are going to starting that induction step. Induction step. Induction step. Let P of n is true for n is equal to k here. Let P of n is true for n is equal to k. Let P of n is true for n is equal to k. True for n is equal to k here. Instead of n in the given statement, we are going to substituting k only here. That is 1 square plus 2 square plus up on so on plus k square is equal to k k plus 1 into 2k plus 1 whole divided by 6. At the same time, you represent this equation number 1. Next, one more is n is equal to k plus 1. Let p of n is true for, let p of n is true for n is equal to k plus 1. In case of n is equal to k plus 1, we must calculate which term we are getting for k plus 1s. See here, in case of given mathematical statement, we have n term is n square. That is the first term, second term, third term, up to and so on. Last term is n square. That's what here we can write Tn is equal to n square here. Then, for example, tk k square, tx x square, ty y square. Like that, if we can proceed for k plus 1 term, if we can put in place of k plus 1, it becomes k plus 1 whole square. Like this. tk plus 1 is equal to k plus 1 whole square. K plus 1 whole square. Now we are going to add in k plus 1 term on both sides of equation number 1. Add k plus 1 term. Add k plus 1 term. K plus 1 term on both sides of equation 1. On both sides of equation 1. To that equation 1, we must add the k plus 1 term on both sides of equation number 1 here. Now let us, we are going to adding the k plus 1 term on both sides of equation number 1 here. Equation 1 is 1 square plus 2 square plus up to and so on plus k square plus, what is k plus 1 term here? K plus 1 whole square. K plus 1 whole square is equal to, what we have right hand side part in equation 1, k of k plus 1 into 2k plus 1 whole dividing by 6 plus k plus 1 whole square. K plus 1 whole square. Now k plus 1 whole square, from these two terms, what we can take common from these two? First term is this one and second term is this one. From these two, easily we can take k plus 1 take outside. If you can take k plus 1 outside, then remaining terms are k of 2k plus 1 dividing by 6 plus k plus 1 here. That is equal to k plus 1 into, here there is no nothing number means, just to consider 1 here. Now LCM for these two fractions is 6. And afterwards take cross multiplication. K into 2k means 2k square plus k into 1 means k, and taking cross multiplication here also with 6, 6k plus 6 here. Next one is k plus 1 into 2k square plus 7k plus 6 whole dividing by 6 here. See, if you can observe, numerator part, it is a quadratic expression. Now we are going to converting into that quadratic expression into product of factors. Product of fact like this: 2k square plus 7k plus 6, and 2 6 are 12 here. And for 12 factors generally we are getting 4k and 3k. Sum of these two 7 and product of these two 12. Product of these two 12 will come here. Otherwise you can take 4 and 3 also, no problem. Then you can convert it into product of factors like this: 2k square plus 4k plus 3k plus 6. 2k take common here, k plus 2, and again 3 take common here, k plus 2. Take k plus 2 common, will get your 2k plus 3 here. Like that we converted this quadratic expression into the product of factors. That is k plus 1 into, instead of numerator part we are writing that is the product of factors, that is k plus 2 into 2k plus 3 whole divided by 6. Finally answer must and should be in terms of k plus 1. At final stage you must and should get the answer should be in terms of k plus 1, means should write like this: k plus 1, that k plus 2 can be written as k plus 1 plus 1. Now 2k plus 3 can be written as 2 plus 1 whole dividing by 6 is equal to k plus 1 into k plus 1 plus 1 into, take 2 common from these two, then we will get here 2 of k plus 1 plus 1 whole dividing by 6. Wherever you are seeing k plus 1 term, just put a small bar on upside of that cube, because this bar represents only k plus 1 term. Because before this in this side, instead of k plus 1 we considered n. That's what, in place of k plus 1 we are going to substituting n only here. N into is equal to n plus 1 into 2 n plus 1 whole dividing by 6. See here, in place of k plus 1 I substitute n, that is n into n plus 1 into 2n plus 1 whole dividing by 6. Finally, we should write conclusion step now. Conclusion step. But what we did in basic and induction, we should write about them only here. Last step is conclusion. It's a common to each and every problem. In the previous class also I have told about this. It's a common to each and every problem here. How means I will show you how to write about the conclusion step now. Therefore, the given statement P of n is proved by the principles of mathematical induction. that is n is equal to 1, n is equal to k, and n is equal to k plus 1, that is for all n belongs to capital N, is the solution for this question. First we finished in basic step, afterwards we finish the solution induction step, and finally we have done what we did in basic and induction, that is we give conclusion to those two steps, that is finally we have done here conclusion step for this problem. Next let us we are going to solving another question. Next one is prove the principles of mathematical induction. Second question, 1 into 2 plus 2 into 3 plus 3 into 4 plus up on so on plus n into n plus 1, n into n plus 1 is equal to n into n plus 1 into n plus 2, n into n plus 1 into n plus 2 whole dividing by 3 here, whole dividing by 3 here. Here also now we are going to giving solution to this question is in the 3 steps, basic step, induction step, and last one is the conclusion step. Now let us we are going to giving solution to this question. Solution to this question is let P of n is true for let P of n is true for n is equal to 1. It is the basic step. Right here, the basic step is this. The P of n is true for n is equal to 1. You collect it loss enter here. That is enter means n of n plus 1 is equal to n of n plus 1 into n plus 2 whole dividing by 3 here. That is 1 of 1 plus 1 is equal to 1 of 1 plus 1 into 1 plus 2 whole dividing by 3 here. 1 into 2 is equal to 1 into 2 into 3 whole dividing by 3 here. 3 gets cancelled. Finally we are writing here 2 is equal to 2 or LHS is equal to RHS. LHS equal to RHS now. Next one is induction step. Induction step now here. Induction step. Let P of n is true for let P of n is true for n is equal to k. N is equal to k means substitute here 1 into 2 plus 2 into 3 plus 3 into 4 plus up on so on plus k of k plus 1, k of k plus 1 is equal to k into k plus 1 into k plus 2 whole dividing by 3. At the same time we represent this equation number 1. Next one more is P of n is true for n is equal to k plus 1. Let P of n is true for, let's P of n is true for n is equal to k plus 1. In case of n is equal to k plus 1, we must calculate k plus 1 term. What we are getting, we must calculate that k plus 1 term at the rough side of solution of this problem. Now in this case, Tn is, what is the Tn term here in this mathematical statement? T1, T2, T3, last one is the Tn. From this Tn term, we are going to collecting that Tk plus 1, that is the k plus 1 term. N of n plus 1 here. In this case, Tk plus 1 is equal to k plus 1 into k plus 1 plus 1 here. That is Tk plus 1 is equal to k plus 1 into k plus 1 plus 1 is the k plus 2 here. It is the k plus 1 term. K plus 1 term is k plus 1 into k plus 2. Now add this k plus 1 term on both sides of equation number 1. That is add k plus 1 term. Add k plus 1 term on both sides of equation number 1. One here. Say here. 1 into 2 plus 2 into 3 plus up down so on plus k into k plus 1. K into k plus 1 is a plus, what is the k plus 1 term we have? K plus 1 into k plus 2 is equal to, what is RHS part? K into k plus 1 into k plus 2 whole dividing by 3 plus k plus 1 into k plus 2 here. Just I added k plus 1 term on both sides of equation number 1 here. Now, right hand side, give solution to this, finally we should get this answer here. If we can give solution to the right hand side of this equation, and finally we should get answer n of n plus 1 of n plus 2 whole dividing by 3 here. Now here LCM is, there is no nothing in term for the second term, it just we considered 1. At the same time, LCM for these two fractions is 3 here. Now first take cross multiplication, k of k plus 1 into k plus 2 plus 3 into k plus 1 into k plus 2 here. What we can take common from numerator parts? K plus 1 into k plus 2 take outside. K plus 1 into k plus 2 into remainder is k plus 3 whole dividing by 3. Then afterwards we must see the answer in terms of k plus 1. Just finally in final step, just we should give modification for the k plus 1 term here. How means I show you now. that is equal to k plus 1, k plus 2 can be written as k plus 1 plus 1, k plus 3 can be written as k plus 1 plus 2 whole dividing by 3 here. On where you are seeing that, whenever you are seeing k plus 1 term, on that k plus 1 term, just put a simple bond. This bond represents only k plus 1 term. After giving representation, instead of k plus 1 bond, just you put a small letter n, because before that, instead of k plus 1, we considered n only. That's what, in place of the k plus 1 bond, we are going to put n only. If you can put n like that, you are getting term like this, n of k plus 1 plus 1 here, k plus 1 plus 1 here. That is n of n plus 1 into n plus 2 whole dividing by 3. Conclusion step is same to each and every problem is same. Already I told now, should write conclusion step like this. And before this, how I have written conclusion step, similarly in the same way, better you won't write conclusion step for this also. Conclusion step is very simple. Therefore, the given statement P of n is proved by principles of mathematical induction, that is n is equal to 1, n is equal to k, and n is equal to k plus 1 for all n belongs to capital N. Like that you should write a conclusion step, you won't write here. Let us now, we are going to solving another question now. Prove by principles of mathematical induction is 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus up from so on plus n into n plus 1 into n plus 2 n into n plus 1 into n plus 2 is equal to n into n plus 1 into n plus 2 into n plus 3 whole dividing by 4 here, n into n plus 1 into n plus 2 into n plus 3 whole dividing by 4. Similarly, the same way how we solved previous questions, similarly we are going to giving solution for this question also with help of 3 steps, basic step, induction step, and last one is conclusion step. Now let us, we are going to solving this question firstly with help of basic step first. Now the solution for this question is basic step. Basic step. Let P of n is true for. Let P of n is true for n is equal to k. N is equal to 1 first. Last one is n of n plus 1 of n plus 2 is equal to n of n plus 1 into n plus 2 into n plus 3 whole divided by 4 here. N is equal to 1 means here 1 into 1 plus 1 into 1 plus 2 is equal to 1 of 1 plus 1 into 1 plus 2 into 1 plus 3 whole dividing by 4. 1 into 2 into 3 is equal to 1 into 2 into 3 into 4 whole dividing by 4 here. 4 4 gets cancelled. And product of all these three numbers 6 is equal to here also 6. Therefore, LHS is equal to RHS. LHS is equal to RHS here. Next one is the induction step. Next one is the induction step here. Induction step. Induction step. Let P of n is true for. Let P of n is true for n is equal to k. N is equal to k means instead of n we are going to put in n only, k only here. 1 into 2 into 3 plus 2 into 3 into 4 plus up to so on plus k into k plus 1 into k plus 2 is equal to k into k plus 1 into k plus 2 into k plus 3 whole dividing by 4. It is equation number 1. Here is equal to, actually we have write is equal to here because there is no place now. That's what here I have written is equal to symbol here. Next one is let P of n is true for n is equal to k plus 1. Let's P of n is true for n is equal to k plus 1. N is equal to k plus 1. Same time, what we are getting for k plus 1 term, we must give calculation part at the rough side of solution of this problem. Say here. Now Tn term we have Tn is here n into n plus 1 into n plus 2 here. First term, second term, third term, last one is Tn term is n into n plus 1 of n plus 2 here. Now Tk plus 1 is equal to k plus 1 into k plus 1 plus 1 k plus 2 into instead of n if you can put k plus 1 ready to is that k plus 1 plus 2 can be written as k plus 3. Now we are going to adding this k plus 1 term on both sides of equation number 1. Add k plus 1 term and k plus 1 term on both sides of equation number 1. Equation number 1 here. To this equation 1, we must add this k plus 1 term. What is the k plus 1 term here? K plus 1 into k plus 2 into k plus 3. That term we must and should add that term on both sides of equation number 1 here. K plus 1 plus 1 into 2 into 3 plus 2 into 3 into 4 plus up on so on plus k into k plus 1 into k plus 2 plus k plus 1 term we must add here k plus 1 into k plus 2 into k plus 3 is equal to loss of RHS part is k into k plus 1 into k plus 2 into k plus 3 plus what is the k plus 1 term here 4 dividing by 4 plus k plus 1 is k plus 1 into k plus 2 into k plus 3. Now here for second term there is no nothing in down range, just we must consider one only here. At the same time LCM for these two fractions is 4 and taking cross multiplication k of k plus 1 into k plus 2 into k plus 3, taking cross multiplication 4 into k plus 1 into k plus 2 into k plus 3 here. Now if we can observe here from these two what we can take common here, k plus 1 into k plus 2 into k plus 3 we can take it outside. If we can take outside then the term will be like this, k plus 1 into k plus 2 into k plus 3, take outside then we will get common term is here k will come and the second term is 4 here, 4 dividing by 4 here. Finally the answer should be in terms of k plus 1. That's why we must give the last step modification in k plus 1 terms. That last expression should be in terms of k plus 1. That's what we are going to give modification to each and every term in the form of k plus 1s. How many I will show you now. K plus 1s. Now k plus 2 can be written as k plus 1 plus 1. K plus 3 can be written as k plus 1 plus 2. K plus 4 can be written as k plus 1 plus 3. All dividing by 4 here. At the same time, put a small bar on k plus 1. Whenever you are going to see that k plus 1 term, on that just you should put a small bar. If you are putting bar on this means this always indicates n term over here is equal to n into n plus 1 into n plus 2 into n plus 3 whole dividing by 4 here. It's only already last one is a conclusion step. Already we knew about conclusion step. You should write conclusion step, but you only write the conclusion step for this because last class in the previous classes also I have given conclusion step and I have written also conclusion step. Similarly in the same way what we have written before this, in the previous problems, similarly same way should write the same conclusion step for this problem also. Conclusion step is very simple. What we did in basic and induction step we are going to about that only here. That is therefore the given statement P of n is proved by principles of mathematical induction, that is n is equal to 1, n is equal to k and n is equal to k plus 1 for all n belongs to capital N, like this. Convolution step means like this, we write here. Therefore, the given statements, P of n is proved by proved by principles of mathematical induction. Principles of mathematical induction. Mathematical induction. That is, n is equal to 1, n is equal to 2, n is equal to k, and n is equal to k plus 1, comma, for all small and n belongs to capital N. Because in this exercise, all problems are defined on set of all natural numbers only. Like that we are writing in conclusion step for this question. Like that today I have finished 3 questions in case of mathematical induction. Next class also I will solve, and that is we are going to solving different types of problems from the lesson mathematical induction. Like all those problems are depending upon only 3 steps, that is basic step, induction step, and conclusion step. Like those problems, next class also we will solve. Thank you very much.